56 cents a box.
Hey guys, welcome back to the wonderful world of Yosh.
Hey guys,
Or the wonderful world of science.
today anyways.
Because we are scientists.
Today we've got some baking soda. It's a base. It's not too exciting until you mix it with distilled white vinegar, which is what we're going to be showing you today. Now, we're going to start off with this little vase. We're going to see what it does on a small scale.
Dude, it is just nippy out. I mean, it's windy, it's like snowing.
It's April 4th,
It's
too.
April 4th, dude, that's insane.
We've got plenty of baking soda. It's 56 cents a box, and you get 16 ounces, 1 pound of it. Not a bad deal.
Remember, safety is important, safety goggles. I mean, you don't want your eyeballs ruined. I mean, that would kind of suck.
Now, this is just a small test.
Oh, hold up. Alright. We're good, we're good.
Okay.
Hey!
And look at that. I dumped just a little bit of vinegar in here, and let's see what happens.
Hey!
And look at that. So, we've got the baking soda and the vinegar. Those are the reactants in this. And then, there's some gas coming out, obviously why it bubbled over, which is... What does it smell like, Yosh?
Gas.
Gas. The product is gas. There you go, you heard it.
Man, it is cold. It's like a salt shaker.
Okay, we're gonna take some vinegar again.
You can actually put, I don't know, not
We're gonna
lot in
put
there,
a
but
decent amount in here this time.
right now, what we're gonna do,
This base is up to here.
you have to put the balloon on
Close.
top. That creates. Alright, now we gotta make sure. Alright, now. And now this should inflate the balloon.
Now, as you can see, this balloon is being inflated quite rapidly, and there's a lot in there. It's fizzing, sizzling.
Look at it go!
I think it's
It might
actually
pop. It might. Let it pop. Let it pop.
gonna tip the thing over.
Just let it pop. Just let it pop.
Okay, there's physical solid liquid in this balloon, and I think it's gonna pop. I don't want it to tip over.
Hold on. Now we gotta pour it back out.
Now it's gonna fall back in and probably react a little more.
No,
again.
this is carbon dioxide.
Okay, tell me about it. What else? Why is
And
it?
now, if we had a candle, it would actually put out. It's heavier than air. So if you had a flame right here and you say poured it onto the flame would go out.
So it's suffocating the candle basically. It's for depriving it of its oxygen.
You see how, okay, besides the wind, it wants to go down because it's actually heavier than the air around us.
So this is
So,
also
no.
a pressurized system as well. It's more
No,
pressure.
if I try to tie this, I was never very good at tying balloons. This should be heavier than the air. Look at that. You guys see how fast that went down? Look at now. Because carbon dioxide is a product of that, it goes straight down. I mean, besides the wind, but look at us go. Dude, science!
Whew, this is exciting. Okay, so we've got these two contaminated jars. Now, that was fun, but we still
Look,
have...
it left a dent in the snow.
That's pretty heavy.
It left a dent.
Okay. We still have about... Okay, so let's fill this. I'm gonna use most of it anyways. I want to see if I can make this a more narrow chute so I can dump it in quicker.
That's
No,
dangerous.
we cannot close the
No
system.
closed systems.
Or
even
we
though-
could die.
I think technically the balloon one was.
It was.
Oh well, it was neat.
It was cool. You liked it.
I'm ready. Whoa! No!
Well,
I was not expecting that. That wasn't expected.
As you can see, it makes quite a mess.
Whoa! No!
Well,
I was not expecting that. That wasn't expected. That was pretty neat.
I mean, I think it went about this
That
high.
was pretty neat. I wasn't expecting that.
Pretty neat. Now, we've got a little bit of vinegar left.
The balloon's gone, guys.
That's literally.
Oh, we're on the highway here, so there's some. No, I'm kidding. Safety first. Hey, you see that? Not being poured.
Okay, so I get that the candle is all like, there's a gas produced, and it like, I just don't fully understand why the candle goes out, because there's nothing even poured on it. So we've decided to call Brooklyn Mott, chemistry expert. She's well over 1,000 miles away in Hawaii. What do you think about this? Why does the candle go out, Brooklyn?
Okay, when you mix the vinegar and the baking soda, it produces the gas. And when you pour this gas onto the flame, the gas that you poured was denser than the oxygen. So the oxygen in the surrounding area just disappeared. It went away, and because the flame had no oxygen to keep it going, it went out.
Oh my gosh, I fully understand that concept now. Thank you, Brooklyn.
You want to give us an action shot of Hawaii?
What?
Yeah, show us Hawaii.
Oh, that, yeah.
Oh, that. Oh, yeah, how about that? Oh, look at that. Beautiful. Alright, gotta go. Have fun. Bye. Welcome back to the wonderful world of science. And today we're back in the studio. And I'm going to explain what's going on out there. Now, out in the field, you guys saw lots of bubbles, lots of reactions, lots of explosions. You didn't actually see that many explosions. You saw a balloon, you saw candles go out, you saw lots of interesting stuff, lots of interesting phenomena. Now let's explain how that all happened. I mean, I don't know how it happened. Do you know how it happened?
So you're saying we created a presentation just to show these people what happened? That's pretty generous.
I'm not sure if we did that, but
Let's find out.
we had the tune. All right, let's go.
Anyways, the chemical reaction. That's what we're here to talk about.
Is it?
So,
I think I might want to get out of the way for this.
So this is sodium bicarbonate.
Oh.
That's a fancy term for baking soda. This reacts with vinegar, which is this equation right here, and then on the other side of the arrow you have the products, which are carbon dioxide, water, and sodium acetate.
What does the arrow mean?
Arrow is like, it's like an equal sign. It's
Equal sign.
It stands for yields.
All right, fair
This
enough.
second equation down here is just another term. It's another way of writing it. It's like, because it can be written either way depending on how the equation or how the reaction takes place. So what's actually happening is this reaction, baking soda and vinegar, when they react, there's two different types of reactions. You have the first, which is a double displacement, where the vinegar reacts with the sodium bicarbonate, or aka the baking soda, and it forms sodium acetate and carbonic acid. Now, the new formula for this is shown down here at the floor. And then continued is the carbonic acid is actually, this is the second part, the carbonic acid is unstable and it undergoes decomposition. So first it's double displacement, then it's decomposition, and then it produces carbon dioxide, which is them bubbles that fizz up, and they filled up the balloon, they put out the candle, where we did all sorts of experiments to show you, to prove to you there is a gas being formed. Now the new equation, the final equation, is as shown right here. Now the fizzing and all them bubbles that come up and why it like shoots out the top of the containers is because that's the CO2, the gas, the carbon dioxide releasing in the form of bubbles. And the CO2 is heavier than air, so therefore it gets rid of the oxygen in the surrounding area of the candle. Yosh will explain more on that.
Alright, he didn't give me the clicker, so hopefully he clicks the next slide for me. Alright, he did. Teamwork. The candle situation. Alright, now let's just get right on into this. Now I'm going to read what's on the slide first. I'm going to go into more detail afterwards. Now the candle situation. A brief description. The candle is using oxygen in the surrounding area, and when we dump the carbon dioxide, which is much heavier than the air, it's more dense than the air, filled the cup onto the small area around the candle. It suffocates it out of oxygen for a brief moment, causing the flame to go out. Now, what's actually going on here? We're going to talk about the candle one first, and we'll go over to the balloon. So, in the reaction, carbon dioxide is actually a product which is made from the reaction occurring, and the carbon dioxide is denser than air. I mean, it's heavier than air. It sinks down lower than air. Say, this is air, is carbon dioxide will go lower than it. And now, when that happens, and carbon dioxide is collected in the cup, since it's heavier than the air, it stays in the cup. And you can almost pour it out, and it'll go down. And when it goes down, it actually suffocates the candle, as shown in the experiment. It suffocates the candle, and the candle, therefore, goes out. Now, in the balloon, the carbon dioxide filled up the balloon, and then once I sealed the balloon, it was pure carbon dioxide in there. So the balloon sunk down as soon as I let go of it. It actually left a dent in the snow. It was so heavy. And, of course, the wind took account and blew it. But what I'm really getting at here is carbon dioxide, a gas, is a product from this reaction.
So, what is the final product of this? Like the aftermath is, it's a diluted form of sodium acetate, which is kind of a foamy, bubbly, it's like liquidy sort of material that isn't the best tasting, smelling, or smelling. Now, the reactants in this product, or in this chemical reaction, are baking soda and vinegar. The products formed, which come out of the final products of it, are sodium acetate, carbon dioxide, and water. The delta H in this reaction is greater than 0. We couldn't calculate it exactly because you'd have to measure out how much of each material you use and then do a long equation from there, and we did it multiple times, so it didn't really work to our favor in that way. Now, because the delta H is greater than 0, that also means the reaction is endothermic, meaning it absorbs energy from the surrounding area into it, which means it also loses temperature. It doesn't get hot, it actually gets colder. And we hope you enjoyed this video, mostly, because we wanted it to be entertaining and educational at the same time. Thank you.
And now the more interesting host is back, and I'm going to give us our credits. Now, this little episode here was filmed, edited, and hosted by Joshua Robinson, yours truly. And this video is also hosted by, researched by, and scripted by Justin Stone. He was our other host you guys saw here. And our main researcher is Brooklyn Ma. You guys saw her. She's currently living it up in Hawaii. Yeah. So we're stuck here. Big thanks to these guys, y'all, for helping, even though I'm thinking myself. It's very... yeah. And a huge thanks to Mr. Lieber, as he was our, persuasion, motivation, moral support. You know, he really touched our hearts by making us do this, and I really appreciate him. But he was our instructor, and I hope you guys have all enjoyed this video. Hope you guys have all had a wonderful life. I hope you guys continue to have a great life as you continue on with your life. I love you. So yeah. I don't have a slide after this. I'm just gonna cut it. Yeah.